Welcome back. Moving forward, I'd like to talk about the IEEE 802 standards. So this society known as the Institute of Electrical and Electronics Engineers, they have set some standards for the networking industry. So we need to know, because these are certain buzzwords that you will find in the industry all the time. So I want to make sure that you understand the fundamentals of what these are and how do they work within the networking industry. So as I mentioned earlier, the IEEE stands for Institute of Electrical and Electronics Engineers. The entire framework consists of the overview over the IEEE 802 standards. So it talks about the 802.3 standards, the 802.2, 802.1, and so on. They go all the way up to 802.12. So for instance, you'll notice that 802 is just the overview and the architecture, and then it has its sub numbering, right? So for example, you'll see 802.1, which is the management of the logical link control, bridging, token, different kinds of topologies, and so on. The most common one that you'll come across is 802.3, which is medium access Ethernet. The other common is you will find the token bus maybe, or the wave LAN 802.11, and so on. So once again, just the concept is that these are the standards set forth by this society under which the entire networking industry works. And as more and more standards are being developed, more and more hardware is being created, you'll notice they conform to these standards. So for example, if you were to go out there and buy a network card, it will conform to one of these standards. Typically in your laptop, in your PC, you'll have the network cable being plugged in, right? So that falls under the 802.3 Ethernet standards. The most widely used is IEEE 802.3, and this is again all across the networking industry. You'll find the 802.3 standards. What this standard does is subdivides the OSI model, recall from our previous lessons. It has 7 layers. So one of the layers is the data link layer, and it divides it into 2 sub layers, which is the logical link control layer known as the LLC, which provides a service interface which is the same for all the IEEE 802 protocols. So for example, protocols on the network layer such as the IP use the services provided by this layer, the LLC layer, and thus in principle works all across the IEEE 802.x protocols. The second layer that this divides into is the medium access control, or the MAC layer, and this defines the method used to access the media being used. So this is the most common one that you need to know, is 802.3 standard. So as a practice and as a homework, explore what 802.3 is and what types of hardware we can use within these standards, and you'll get an idea. And that's your homework, by the way. Okay. Next, I want to compare side by side just the IEEE 802 layers within our OSI conceptual model. So on the left, you'll notice it's the 802 layers in the OSI reference model, and here again you'll see that the data link layer is being divided into logical link control and media access control. And on the right side, of course, our famous OSI model that we took a look at in previous lessons. So by this time, you should have memorized all these layers, right? And the names of these layers and what happens at each layer as data flows throughout the entire model. Additional things about Ethernet, IEEE 802.3. Certain buzzwords that you'll find all across the industry wherever you go. The 802.3 standard is most commonly known as Ethernet. Okay, so you'll come across the terms Ethernet all the time. The physical layer of this standard defines the transmission related properties. So for instance, the medias that you see in the chart and topologies are defined. So the first name that you may come across is 10-base-2 networks, or 10-base-5 networks, or 10-base-T based networks, or 10-base-F based networks, right? So if someone says to you that I have implemented a 10-base-T network within my organization, this would imply that they have used a twisted pair cable. The maximum length of the data signals is about 100 meters. Can have up to 1024 stations, and that network will be using the star topology. So just by saying the name, you would have to know exactly what goes with the name, right? Pretty much. And that's a standard. Similarly, if you're using 10-base-2 network, that means the medium is being used is the coax cable, right? Or the coaxial cable. And then the length is also provided, the max stations, and the topology is bus, which is pretty much a straight line. So if you have a bunch of computers connected together in one assembly line, for example, you can have up to 30 stations, and you can connect them with a 10-base-2 network. So these are important. As you get into the industry, you'll come across these terms. All right, let's summarize and let's revise. So here's the question for everyone. All people seem to need data processing. We memorized this in our previous lessons, right? These are the OSI layers. So let's go ahead. What stands for A? Application. Great. Then we have the presentation. Perfect. Next is the session. Transport. Network. Data link. And then finally the physical layer. Perfect. So here it is. These are the OSI layers. So the better you understand, the easier it is. Okay? So I hope this helps. Practice, and let's move to the next lesson.